What is edge computing? In the healthcare, in the environment monitoring system, smart city implementation, a lot of smart sensors are deployed here and there to capture different data, different signals, so that we can effectively monitor that. So at different ages, different nodes, you can deploy a number of sensing elements, sensors, so that you can capture the information and process in a better way. You can interpret there itself. That is what is called as edge computing. Say you can deploy a number of small sensors in rural areas where you can collect the medical or biomedical related data, and the person who is sitting somewhere as a physician or radiologist can diagnose and suggest the patients and the people who are living in the rural area. So let's understand what is edge computing. So is an emerging computing paradigm as a range of networks devices at or near the user. Either network or the devices are available near the user. You do not have to go anywhere. It's processing data closer to where this is being generated. You can collect the data as well as you can interpret and process the data. That ability will be there. So at sensing node, there may be some microcontroller based, system that will help to understand the data, enables processing at increased speed and volume because you are not depending on cloud all the time. It allows companies to improve how they manage and use physical assets and create new interactive human experiences. It use cases, for example, self-driving car, where you have thousands of sensors and they are capturing the data and interpreting the data in real time, processing the data. Autonomous robot, autonomous vehicle, autonomous wheelchair, automated retail, smart healthcare, and so on. So this is, cloud where data center is there, and it edges real-time data processing, data caching, buffering, optimization, machine to machine, where you can connect a number of devices with the Internet of Things, medical Internet of Things, industrial Internet of Things, or Internet of everything. You can connect a number of things, and you can, collect the data, interpret the data, process the data itself. So what are the components which are used? Number one is, the devices, network, and on-premise infrastructure are required. So edge devices like smart speakers, smartphones, watches, phones, devices to locally collecting or collect and process the data while touching the physical world. So locally you can collect the data, process the data, and then connect with the entire real-time world. IoT devices, point of sales, systems, robots, vehicles, sensors, and so on can all be edge devices. Not only sensors, but robots, vehicles, and other things. Second is the network edge. When a separate network is involved, this is just another location in the continuum between users and cloud. So you can use even the broad network, you can have your own network. 5G brings extremely powerful wireless connectivity to edge computing with low latency and high cellular speed that brings exciting opportunities like autonomous drones, remote telesurgery, smart city projects. So there you can have access to the network, and at different small network you can deploy a number of components of either smart city, telesurgery, telemedicine, and so on. Then comes on-premises infrastructure that is used for managing local systems and connecting to the network, and could be servers, routers, containers, hubs, or bridges. So what are the benefits? Faster response time, you don't depend on cloud, reliable operations with internet connectivity, security and compliances are there, cost-effective solutions you can get at edges or nodes, interoperability between legacy and modern devices. So edge computing brings data processing power at node of the network closer to the source of data where the data is being generated. For transforming, this is simply can be used to transform businesses across every industry, from customer engagement and marketing to the production and so on. So you can see the diagram where edge nodes are there, devices are there. So combined with other technologies, what are the technologies which are combined? Like 5G is very important, and that helps to reduce very less latency time, the response time, because the communication becomes very fast. So the communication also becomes seamless because of 5G. And since we can compute and process every information at sensor node itself, therefore latency time, which is always depending on cloud computing, they are bringing back, that is same. IoT and connecting devices are unique data resources or sources that need to be secured and registered in the cloud. Then containers, which provide standardized deployment environment for developers to build and package applications where you can put everything, can be deployed on various hardware regardless of device capabilities, settings, and configurations. Software defined networking, it allows users to configure overlay networks, makes it easy to customize routing and bandwidth to determine how to connect edge devices to each other to the cloud. Digital twin, where is a critical enabler that organizes physical to digital cloud to edge. So you can have a virtual replica of a system unit node, and you can better, monitor, maintain, or understand the system with the help of digital twin. It is used for retail, at different levels. You can have a number of zone sensors, robots based applications which could be connected with the cloud for providing different services in the retail sector. Healthcare, be it accelerometer, ECG, EEG, location GPS, microphone, oximeter, pressure thermometer, and so on. So you can, just acquire a number of biomedical or medical parameters, health parameters, from different parts of the body with the help of smart watches, camera clips, sociometric badges, headbands, and so on. And then you can provide the real-time monitoring and control the entire health of the human. So healthcare is a major area where the edge computing plays significant role. Then comes smart city, smart environment monitoring, where you can have Wi-Fi based systems to either control the radiation, control the pollution, reduce the traffic. You can monitor the traffic. You can have a smart parking, smart transport, a smart environment monitoring system, a smart pollution control, and so on. That makes your city as a smart city. So at edges, you can compute a number of things. You can capture, process, and compute so that your city becomes, a smart city where you can monitor everything intelligently. Industry 4.0, it's the transformation of industry with the help of IoTs and sensors. There, the industries have a number of components, number of sectors where you can deploy at different points, different nodes where you can just capture, process the data there itself, and make the efficiency of the industry 4.0 outcome better and better. Lastly, power monitoring, smart grid system, power monitoring system, advanced metering infrastructure you can have, smart energy system you can have, and all of these power monitoring, metering infrastructure, grid management can be connected with the cloud, and you can better, manage the smart grid and smart power monitoring system, and you can also save the power. You can distribute where you can provide the power wherever it is needed, and you can just stop the supply wherever the power is not needed. That is smart management is very much possible with the help of edge computing, which is deployed for smart grid and power management system. So thank you, hope you like this lecture on edge computing. Just it gives an overview definition of what is edge computing, what are the potential areas where edge computing is used, and how it is used. It brings all the capabilities of the sensing technologies, IoTs, and artificial intelligence at different nodes at user level, at the node of user where the data is being generated. Thank you so much. If you like this video, please comment on the video, spread with your peers and contacts, and please do not forget to subscribe the channel. Thank you so much.